Okay, welcome everyone. Youngri and I are going to be running this workshop. My name is Adam Sales. I run the statistical consulting office in the college. So, and Youngri is the GRA. And let me tell you, before we actually start talking about our software, I want to tell you a little bit about how the consulting office works. So it's called a SMARTER, which stands for Statistics, Measurement, and Research Design Techniques in Education Research. I didn't come up with that, but so we're here for any kind of quantitative analysis support in education research. And that takes on a few different parts. One of them is we do free consulting meetings. So faculty will meet with me and grad students will meet with Youngri. And you can talk about any stage of your research project between, you have an idea of what you want to study and you're trying to figure out a way to make it into something that you could study with data, quantitative analysis, in a very vague conceptual stage, all the way down to you have results and you want to make sure you're interpreting them right. We're happy to meet with you and to talk through your data analysis with you. We also will help write up grant proposals, and then if in that case we'll be on the grant, you'll put us on the grant and we'll help with the data analysis and write up and everything of that nature. Or we can, I guess this is more for faculty than for grad students, but you can do contracts with us, so we'll do your data analysis if you set up a contract agreement with us. And we also do these methods workshops. So this is one example. We're going to do one in Tableau data visualization in November. That just went up on the events website. Youngri is going to run that one. And in the past, we've done things on propensity score analysis, on network analysis, network data, social networks, causal inference, and general mediation analysis. We're actually always looking for kind of ideas of things that people want to learn about. Last year, someone asked us to do something on reproducible research or working with data. So we did one on that. So please let us know. After this workshop, we're going to send out a Google form asking you for like ratings or evaluations, and at the bottom you can write any ideas of a workshop that you're interested in seeing. So that's who we are. The way this workshop is going to work is it's going to be two parts. The first part is kind of a basic introduction to our software, how it works, how to load in data, how to kind of do calculations, and Youngri is going to run that part. And the second part I'm going to do, which is some very basic statistical modeling and graphics in R. And just so everyone knows, the workshop is being recorded. So if you ask a question, then your voice might show up on the cloud. I hope that's all right with everyone. But people often want to see these workshops who can't make it, and so that's how we do it. Right, so let's move on. This is Youngri. I'll be hovering in the back of the room, so if anyone has any questions, I can come and help you out.
Okay, thank you, Adam. Okay, welcome to the workshop. So has anyone has problem with installing R or RStudio? Everyone's perfect? Okay, perfect. Okay, so let's start. First topic is why we use R. So first of all, the important reason is R is free. I like this reason, not because this is free for me, but this enables the researcher like all around the world can like access the data and then use the statistical modeling they want using the R. So, and that is great advantage of R. And then second of all, if you use R, you can start with from the data cleaning and then analyze and then reporting in R at once. So that is really great. So if you try to use R and then start from the data cleaning, that'll be the awesome choice for you. And then the third is if you use R, one of the great feature is that every researcher like all around the world try to like make some like great packages that you can use R. So for example, if they create some new method, they try to like make a new package for R so you can use in R. And then after that, you can use like deployer to clean your data, and then ggplot, which is really great package to like plotting your data, and that'll be really awesome. And we're gonna talk about a little bit about ggplot later in this workshop too. And then finally, I really like this feature, which is that if you write the R script, you can replicate your analysis like again and again with another data. So I think this is really great feature, and also is free. And then there's a reason that why we use RStudio. So everybody installs RStudio, and can you like see the RStudio for just 1 second? So this is RStudio. We installed R, so it seems like it's already enough, but we try to use RStudio instead of R. So here is why. You see that there are 4 screens in the RStudio, right? Left upper side, here is the R script that we write something, right? Like this. Can everyone see this? Yeah, I increased the font size really a lot. And then, so if you write some R code, you can just save this R script and then see this later. So this is really great feature. And then after you do something in this R script, you can see every result in the console below. This part is called console. So if you write something and then you run something, then you're gonna see the result in this part below. And then what this part does is the right upper part is you can see your data here. So every time you save some data or assign a vector or matrix, anything, you can just see your data here. So you can check that what data you actually have in this RStudio. And then for right below part here, you can see this tiny folder. This is actually the same for file folder that you usually see in your screen. So you can also see your folders here. Or if you plot something, your plot would appear here. There's nothing here yet. And then the package you downloaded, I downloaded package a lot, so there's a many package, but probably you won't have this many package yet. And then help file, viewers, this kind of screen can pop up down here. So this is really useful when you use R. So actually, it's okay to use R instead of RStudio, but I strongly recommend to use RStudio at the first time because it'll be useful to see all of these like characteristic data plot every time at once. Okay. Go back to the outline.
What if there is a package that we're interested in, but we don't see it in our?
Yeah, sure. If there's a package that you want to download it, there's some code named install package that we're gonna go through in this workshop. Oh yeah. So outline of the workshop would be like this. I'm gonna just tell briefly how I think you should interact with the context of the workshop. And then we're gonna do a little bit of calculation in R. The calculation is not a focus, but the focus is to make sure that what notation this RStudio use. And then a function of R, the function is really important. And then we're gonna go through how we like call the data to the RStudio and then how to work with the data and then try to save it after that. And then simple plotting and then modeling after my session. Okay, first of all, if you have a question, just raise your hand and ask question. And then we already shared all the code script in the box folder, right? So please download that R scripts, try to use it while I was going through the code. That would be helpful. And then this is a slide we made for your reference. So I'm not gonna go through all the slides, but I'm gonna go to the RStudio and then type some code with you guys. So keep this slide just for your reference. This has all the code and all the explanation I'm doing here. Okay, let's go to the R. So, for R script, there is something I want to mention before I start to write some code. There are easy way to comment on the R script. Like for example, if you're writing the code as the code I write, you want to like put some comments that you just want to know. In that sense, you can just write hashtag here and then put some comment like this. If you put hashtag, this means comment to the R, so it will not gonna run it. So you can put any comments that you want. And then the code block, the usual code block would look like this. So the brown color is the comment, and then the R norm is some kind of function that creates the normal distribution value, about 10 value of normal distribution. And then after that, we get some results down below. Actually, in the RStudio, this result would pop up in the console in the R script part. And that is that. Okay, interact with the content. I know that coding is hard at the first time. I did that too, and I spent like so many time working on R, try to run it, try to get used to it. So I understand. So if you have a question, don't just like keep that question in your end and just Google it, but ask your friend, ask other people to get some help. That would be really helpful to learn the new stuff. Okay, I can just skip that. Okay, I'm gonna go to the R. Please open your RStudio from now on. There's R script, but you can just see the R script and then just run the script that we already showed you. But I actually recommend slightly to you that you can just write the code as I write the code. That'll be helpful to like memorize the function or the notation I'm using. That was helpful for me to memorize the function at the first time. Okay, so first is R is calculator. We're gonna do a little bit of calculation, which is really easy, but not for the calculation. The focus is on the learning the new notation. So so most basic function is like plus, minus, like multiplication or division, something like that. So we're gonna learn about that. So first is addition. So for addition, like for sure we use this plus sign here. And then when you want to run this one, there are like some like one way to run this. First of all is just click on this line like this, and then there's a little option called run. You can use this one, and then the result would pop up here. And then other option is if you use Mac, you can just pull option and then enter. If you use Windows, that's gonna be Alt and then enter. It'll be much easier than just click this run every time, right? So I recommend you to use this shortcut. And then let's do some subtraction. For subtraction, we use minus sign. Pretty obvious, right? How many of you use Windows? Oh, okay, perfect. Oh, if you use Windows, Control Enter gonna be work too. Okay. And then for division, we use this slash sign. 6 divided by 3, which is gonna be 2, right? And then for square, we use this sign, 3 square, right? And then basic R, when we try to calculate something in R, it follows the PEMDAS rule. I believe you all know this PEMDAS rule, right? First, P goes for parentheses, so every parenthesis will be calculated first, and then exponential for E, and then MD for multiplication and division, and then for last thing, addition and subtraction goes to last. So you should be careful when you write something here. Like for example, if we want to calculate this long calculation, the parenthesis goes first. So this must be calculated first, which is 2 here. And then this exponential would be the second, right? This is 8. So if you calculate, if you run all of this line, it'll be 16 because 2 times 8 is 16. Clear? Yeah. Okay. But if we change a little bit of this line, it'll be a little bit different. So let me put some parentheses around here. Then the order is going to be different. So it'll be 2 here. 2 times 3 is 6. And then if you run all of this line, that'll be 2 to the power of 6, which is 64, right? So try to remember the order of the calculation when you really put some calculation here. I really use R in calculator sometimes because the great thing R is you can just put all the code in the script and then memorize it. When you use the calculator, sometimes you forget what really you put in the calculator, right? So I can just check what I did in the calculation, right? That is a good characteristic. And then there is some case that we want to evaluate if this is true or not. So for example, you want to like subtract some people that meet some criteria, like for example, like age under 5. So you want kids age under 5. So if you want to do some that kind of like meeting the criteria or not, you can use this like less than function. It'll give you if this is true or false. So 5 less than 5 is of course false. But what if we want to write some kind of like less than equal? If that's the case, you can use less than equal sign like this. Then it'll give you true. It'll be exactly same when you want to do the opposite. This is greater than equal to 5, which will give you true. And then important thing is this is one that I want you to memorize it because this is really tricky at the first time. I did this mistake a lot because when you want to write the equal sign, if you want to write equal sign like this, it'll give you error. That's because this equal sign is not really equal sign in the R, but this means assignment. Yes.
Is there a lot of like correlation from like JavaScript in R?
JavaScript? I guess so, yeah. I don't really know about JavaScript, but I guess the code will be similar. Okay. Yeah, I think I heard about something like that. Yeah, yeah, that's right. So that's why we put like double equal sign here. This is equal, so it can be true. Okay, so, and then what if we want to see if this is not equal to something? So for not equal sign, we cannot put not equal sign in the R, so we use this sign. The exclamation mark and then equal is not equal here. So see, this is true. And then we can do something like this. Instead of just putting like 64, we can use 2 to the power of 6 and it'll work too. False. And then R know the word true, false. So from this section, I'm gonna tell you about and then or operation. So if you want to evaluate what if true and true is true or not, it would give you truth because both of them is true right here. And then if you put true and false, what would be the answer? False, because one of the two was false here, right? This is the characteristic of AND operation. And then for application, you can do something like this, like 1 equal 1 is true here, right? And 2 equal 2 is true too. And then if you evaluate this, it will give you true. What about OR operation? OR operation. For OR, we use this notation, which is above the enter in keyboard. I'm gonna evaluate true or false to see if this is true. It's gonna be true because either two of one is true, so it's true. And then what if we put false, sorry, false and false? It'll be false, right? So for example, you can use some calculation here for application, like 1 equal double equal sign, 1 equals 0 is false. And then 1 not equal to 0 would be true. Something like this. So this was the really easy calculation for you, right? But the important thing is not the calculation. Try to memorize the notation I just used, like double equal sign, not equal sign, like less than equal sign, something like that, right? Okay, from now on, I'm gonna assign some value to the object that we're gonna use in R. Suppose we have some vector or data that we want to use in R, but that data is too large. We cannot just use that data again and again in R, just write out everything in RStudio, right? So we're gonna assign those large data or vector into some object that we decided. This is what assignment does. So for example, if I want to save value of 3 to the box, I can name box like anything that I want. So I'm gonna just name this box as X, and then assign this. So what it means by this is I'm gonna put this 3 to the X. So that's why we use arrow sign. This arrow sign means assignment. And then there is shortcut to make this assignment. I already told you, right? So please use that shortcut. For Mac, it's gonna be Option minus. For Windows, it's gonna be R or R minus, right? Okay. So if you assign this, nothing's gonna pop up in the console. It just show you what you just did. When you see the data part here, it's gonna show up like this: X, the object you just made, and then the value of 3, right? And then if your environment is not look like this, maybe the option would be different. My option is grid right now, but if you change this into the list, it will look like this, right? But I prefer grid because it's easier to like erase something here, like this, and then if you click this room, you can just erase this object. You can just select anything you want, and then if you want to if you want to make this X to show up, you can just call this X again, and then it'll pop up in the console. You can change the name of this object, like maybe 5 squared 25, and then if I assign this, my 5 square data gonna be pop up here, and then maybe year can be 2019, and then if I assign this, my year is pop up here, and then not gonna pop up in the console, but you can just call it okay, like this. Okay, so okay.
Do we ever have to end a line with, like, does the program automatically assume that at the end, at each new line is a new line of code? Like, do we ever have to use semicolons or anything?
No. You can just enter it and then you use that as a new line. Okay, and then using this object, we can use we can do the new calculation like X. I'm gonna assign X plus 1 to the X again. Then nothing happened, but we can see that this x was 3. So after I add the 1 to the 3, it would make 3. It would make 4, sorry. So x now became 4 like this. And then can do a new calculation like this. And that would make x as a 20, right? I keep using another option, which is you don't need to like write this x every time. You can just go for this x and then drag this x, and then if you call it, it's gonna do the same thing. So that's why I'm just keep trying to do. Okay. So when you want to call this x again, you don't have to always like write this x every time you want. You can just go for this x and then drag it, and then if you run it, it will just call my x again. Yeah. Okay. So you can do this for other objects that you already made. Like for example, I wanna see what if I subtract 1 from the last year, which is 2019, and I'm gonna assign this to last year, and it'll make my last year as a 2019. Yeah. Okay. Yeah.
How does the R recognize the first X?
X.
Yeah.
So it doesn't recognize as a first X and second X. It just like rewrite the X every time. So after I calculate all of this X is not a 3, not 4, but just 20 right now.
Oh,
Yeah.
So it remembers the last.
Yeah, it remembers the last one. If you want to keep the 3 or 4, you can just change the name. Like for example, if you put this x1 as a 3, and then x2 as a x1 plus 1, that'll remember everything that you assign. Yeah. Okay, let's go for function. There's like bunch of function, like huge amount of function out there that does really great things in R. And then the basic feature of function is that you have a function. For example, let's have a norm here, R norm, which makes you the normal distribution. And then there must be some argument that require you to write something. For example, for this function, this R norm is something called function. And then there must be some argument after that this function require you, which is n, mean, and then standard deviation. So interesting about RStudio is that when you write R norm, even if I didn't finish the function yet, it just R norm just popped up, and so you can just enter and then select it. This is great. And then after I write R norm, if you see your screen is really tiny font, but you can see that there are n and mean equals 0, and then standard deviation equal 1, and then you can make this as a hint for your function. So this is why I wrote this. And then the reason why the mean is already 0 and then standard deviation already 1 in that function is that is the default for this function. So sometimes functions have a default and then sometimes they're not. So if there is no default, you should write something on it. And then if there is default, you can just go for it. Okay, so if there's function that you want to use, but you don't really understand what this function does, there is helpful website that just automatically pop up in the RStudio. So for example, if you want some help page for the R norm, you can just put question mark here and then write R norm and then try to enter. The font is a little small, but you can still read it in your screen. I don't think you can read it here, but so if you look closely, there is a title of the function and then a simple description and then usage. So you can see there are D norm, P norm, Q norm, R norm, like bunch of normal distribution. And then for argument that you're gonna write while you're writing the function, detail, value that you're gonna get, and then you're gonna have to see the source and reference. But example is sometimes really helpful because this example has a example that you can actually like apply to the R script and then write it. So if there's a function that you want to have some example, try to look up this help page. For some function, you should put like double question mark, then it'll work. But for this one, we can just put just one question mark like this. Okay. So we're gonna learn.
The question mark just for
Mhm.
The question mark just well for function.
Question mark?
Else you want to say?
For example,
I don't know.
usually question mark work for function. Okay, and then we're gonna learn simple function in R, which is called combine. We don't really write all combine, but we use C here. Like for example, if we want to make a simple vector like 1 through 5, we can make 1, 2, 3, 4, 5 like this. And then when we enter, the R will give me 1, 2, 3, 4, 5, but this is not saved yet, so we have to assign this to data 1, maybe. So if we assign this vector to the data 1, and then we can call this data 1. And then there are other functions that easily you can use is like mean function. So for example, if I write can I get a mean of data 1, then it'll give you the mean of the data 1. And then you can actually like skip this x equal sign. If you write like this, it'll just understand what you're saying. And then we can assign this mean of data 1 into the another object called mean data 1. And then if we call this data 1, it'll just pop up as a 3. What if we have a missing data in our data? Missing data is sometimes a like big like problem in like analyzing any data, right? So let's learn how to control this NA here. Let's make 3 as missing data. This is not applicable. If we type NA here, I just don't understand this NA as a missing. So you can see the color is a little different, right? Like blue or something. So let's make data 2 like this. So if we call data 2, just NA, that's gonna pop up. This is not like character NA, but just missing data here. And then suppose we want to see what is the mean of this data 2. So as we did for the data 1, we're just gonna call data 2 mean. And then let me assign this mean lower dash data 2. It worked at the first time, but if you call this data, it'll just give you NA, which is just missing. That's because one of the missing data is already in that vector. So if there is missing data, you won't gonna get any mean or standard deviation of the vector. So we must do something about this missing data. So good way to get rid of this missing data is we can get rid of this missing data in the code which called is NARM. I think it stands for missing data removed. You can put this true. If you click it, it does delete the tree and then calculate the mean. So after you're doing this, you will get 3. Does anyone has a question? Okay, perfect. So let me check if mean of data 1 and then mean of data 2 is the same. There is function name identical. I didn't type a full identical. I just typed ident and then identical just pop up. And then for argument, I put mean data 1 first and then mean data 2 after that. I don't think it doesn't matter whether you put as a first one, but let's see if this is true. So it evaluates if 2 is the same value, so it says true. You can also use the double equal sign that we already learned here. Mean data. It'll give you true too. Another function that you can use easily is a sum function, data 1. We call that data 1 was 1 through 5, right? If you sum it, it'll just give you the 15 here. And then if you want to calculate the standard deviation, that'll be SD. So you can put a little comment here, standard deviation. And for other function for your information, there's like median function, data 1, or IQR function, data 1. And then you can also get range of the data, like 1 through 5. That'd be 1 and 5. Minimum is just mean. This part is quite easy. But try to I understand you can just you cannot memorize all of this at once, but try to like memorize some important function, because I also took this R workshop at the first time, and then what I did after that was, while studying the R Studio again and again, I just go back to this slide and then study this slide a lot of time to like memorize and get used to this R function. And then the next thing will be the length of the data 1, which length will be 5. Okay. Anyone have a question? Am I too fast? Is it okay to type thing? Okay.
If anyone is stuck in following along,
Yeah, Adam can help you. Just raise your hand. What if we want to write some vector, but that vector is like too long to write all of them? Like if you want a vector like from 1 to 100, we can just type all that 100 value, right? So there is some really useful shortcut. Like for example, if you wanna assign like 1 through 6, let's try this. This is short, literally. But if that is getting longer, it's gonna be hard to write all that, right? So there is one shortcut that you can use is 1 through 6. This you can call this 0 or something. So if you assign this to y2, and then if you call y2, it'll just give you 1 through 6. You can just apply this to 100, it'll just give you 100 value. Okay. And then after this, making this vector, you can do some calculation with this vector as well. Like for example, remember that we assign 20 by calculation on x. So x is 20 right now, and then y is 1 through 6. So what will happen if we do some multiplication, which is x times y? What it does is 20 times 1, 20 times 2, and then do everything through the 6. So this is how it works for the multiplication. And then we can do this for evaluation too. Like for example, if we type x greater than equal y, double question mark, and then it says true, false, 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 right? Because the first thing here is 20, so it was same as the x, but the rest of the y is greater than 20, right? So that gives true and false, false, false after that. Also, you can assign some sentence here. Like for example, you can assign greeting. Hello, how are you? But for the sentences, you always should put some quotation mark like this. What I just did is just drag the sentence and then put one quotation mark, and then it'll just automatically give you the 2 quotation mark. And then also good things about RStudio is that if you put just one quotation, it'll just give you the 2 quotation mark. So you don't have to write 2 quotation mark like twice. So this is also the good thing. Let's assign this and then call greeting again. And then it'll give you, hello, how are you? Why the spelling is like that? Nobody told me. Okay, I'm gonna do this again. Okay, so and then we can just assign like bunch of the sentence at once, like using the combine function. You can just guess and try to type it. Just for example, I'm gonna type it while you're thinking about that. You're gonna use C, and then what I'm going to do. Hello, how are you? And then what I'm going to do is put comma here, and then we can put some more sentence here. I don't skip the rest so far. You can see the R screen. Oh yeah, sorry. And then we're gonna see there's like 2 sentences here. Okay, so there's some caution in making a vector, which is you cannot add the sentences and the value at one time. Like for example, if we combine like A, E, C, and then I want to put 1, 2, 3 like this. It worked. So if you call this data again, it would just give you the ABC and 1, 2, 3. That is correct. But the problem is, as you can see the result here, it has a quotation mark. That means this number is changed to the character right now. So it is not the value anymore. So if you try to average this data, it would not work because now everything is character in this vector. Okay, so I'm gonna give you a little bit of exercise. You can see the page 40 in your slides. Let me find it too. Okay, this is a picture of Gauss. Why a picture of Gauss is here? Does anyone guess it? You can see the question. You can see the question. Okay, that's the formula for normal distribution. You remember? So it's Gauss Gauss distribution. So that's why Gauss picture is here. So here's a simple question that you can answer right now. As far as we go through all the vectors and simple calculation, you can solve this question. So try this. I'm gonna give you 3 minutes. 3 minutes. Okay.
It's
Okay. We're gonna solve this question from the first. So first one is create a vector named x with all the integer from 1 through x, which is 1 through x, right? And then assign to x. Then sum of x gonna be sum x. And then mean of x. And then standard deviation is, as you see, the SEX gonna give you the standard deviation. And then for the last one, you can just assign all of the formula into the y, and then parentheses for just in case, and then x minus mean of x, and divide by standard deviation of x, and then you will get this. Yay. Okay, so we're gonna just dive into the data part. So finish the calculation, finish all the function, and then we're gonna open the file and then try to call the data that we want. So first thing to do is get to know your working directory. Working directory is the file that you put the data, your data that you want to conduct in this R. So try to write that word working directory, which is that WD. Then it would give you the file name that you're using with your RStudio right now. If your depression file is not on that folder, you have to switch to the working directory. There are like a bunch of ways to switch the working directory. First way is to go for session, go to the set working directory, and then you can choose directory here. If you click this, you're just gonna see all the folder that in your PC. So you can just select the folder that has a file name depression that we share you guys. Or you can find a file here. See, there's a file name, and then if you click this more, it says set as a working directory. This is also the easy way to set your working directory. If you have any problem with setting the working directory, raise your hand and I'm gonna help you to set the working directory because this can be the hard part at the first time. So just raise your hand if you have a problem. And
Hi, sorry, I have a question.
okay,
This looks different on my Mac, where I don't have that bar that has the file to edit the code session.
if you're a Mac, can you just roll up your cursor?
Someone else is raising their hand.
And then the session gonna be pop up, isn't it? The file and then every option. Or you can just find your folder here, somewhere here, and then just set your working directory.
Okay. Thank you.
You're welcome. Okay, so most files that are used is CSV, and you can easily make this CSV file. Like for example, when you go to the Excel, this is actually already CSV file, but I just want to show you. If you go to the file and then try to save this file, you can select the type, and then you can just change this as a CSV, like comma delimiter, and then save. It'll make you the exactly same file as an Excel file, which is a CSV file.
The working directory is supposed to set up like to connect to what exactly?
Connect.
Computers, files?
Okay. So let me call this file now. Is everybody okay with the working directory right now?
No,
Okay.
Who needs help?
I do.
Mhm.
I did setting it as a. CSV, but it's a file.
Yeah.
Excel.
Yeah.
Oh, yeah. So,
Because I guess CSV file is much faster in R, not with Excel, and then it'll be like much faster to write with you to save in the folder. Yeah, I think that's why. Yeah, you can still use an Excel file or any file that you want with another package, but that is the case that you have to use another package. So
Okay.
I prefer to use CSV.
I was trying to set it in the panel, like that's not, it kept setting it to. I keep finding.
Okay.
yeah, that's what it was.
Did you set the? Can you find the file folder that your file is in it?
Okay. So that's, well, run the-
Yeah, I know. I don't know where
wherever you say. If you do is try. Finish, reproduce. Oh, right.
Okay. Oh, Adam's gonna be go first. Yeah. Your question? Yeah.
Yeah, just we.
Huh? Yeah.
This is connecting your RStudio with the loader that you save your file and then do the work. So if you save a new data from the RStudio, that data will go to the dev folder. Oh, okay. Okay, so you're just setting the working directory. Okay, just get your wherever location, wherever. Okay, thank you.
Everyone okay? Okay, let's go for it. If you look at the depression data,
Can you just show me, did you save that like from the working group, save that as Excel?
this one,
Yeah.
this is already
Sorry,
CSV file.
I thought you were saving it.
No. Oh yeah, just gonna show you the example. Okay, this data has anxiety data. So this is BAI is back anxiety inventory. And then Hispanic is whether you are Hispanic or not. Race is here. And then age, you can see some missing data in this age variable. And then SES, and then this is the time measurement, 1, 2, 3. And then you have gender. We're gonna call this data into R. If you set the working directory correctly, you can just call this data into the R using the function name read CSV. So let's put some depression object first. We're gonna assign some data to this depression object. And then the function is read.csv. It's just gonna pop up. And then what you're gonna do is write the name of the file, CSV. And then there are some options that I want to put here, which is string as a factor, it pop up. Which means is that if you whether you're gonna make this all the variable as a factor or not, I'm gonna put this as a false. Because I wanna keep, if the variable is already numeric, I just want to keep that as a numeric. If that is character, I just want to keep that as character.
The data is totally there.
Yeah.
Don't take it.
If you set the working directory correctly, it would work fine. And then after you do this, and then after you like follow data correctly, it would just pop up in here too, in your environment called depression, which has 100 observation with 9 variables.
Mine is not importing, it's saying that the CSV. Oh, it requires an updated package.
Oh, okay. After calling the data, you can just like overview this data with some function, which is really useful. First one is head function. It would give you first 5 rows in your data. Question?
Yeah, it's after I like put the depression and to the first seal error.
These errors?
Yeah, I didn't see anything.
Okay.
I pressed.
Okay,
Completed.
thank you.
I'm supposed to put it, the file name.
What work here? No.
Okay, thank you.
Everybody okay? Any question? Okay. After this, there are useful function name structure. Try this function name structure. Then you can see the type of this variable. For example, you can see the anxiety is integer, and then this is logic, and then the white unknown which is race is character right now, and then there's a numeric which is come as an integer, and then the last gender variable is a character. So this is useful function that get to know the type of the variable.
What does it mean if a variable is logic?
Logic, this is just evaluation, so that's why it has false, false, true, true, true. It only happens to this true, false.
Sorry. I'm sorry, can we take a step? Couple steps back?
Okay,
Would you mind explaining one more time?
Uh-huh.
Number 95, line 95,
okay.
and how you called the data?
Oh, this one?
Yes.
So the function you call the data into the R Studio is read.csv. This is how you read the data CSV into the R Studio. After that, you put name of the file. It should be like really specific. And then string as a factor. False is that you can decide whether you're gonna call this data as a factor. But it doesn't really matter. You can just erase it if this is not working. It happened to the other laptop. So, and then assign to the diversion. For those of you who couldn't listen to the head function, is that if you click run the head function, it would give you first 5 or 6 row of your data. So you can just overview of your data. And then for structure, you can see the type of the variable. And then if you want to only see the variable's name, the name function would do the job, which is look like this. If you have a data with a lot of variable, you would definitely need this function. And then if you want to change one of the name of the variable, you can try this. First, we're gonna call first column of this data, which is BAI, which is not really straightforward. This is anxiety inventory. So I'm gonna change the name of the BAI as an anxiety, like this. So I'm gonna assign this anxiety character into the first column of the data. So after doing this, we call the name of the diversion. You can see the BAI is now changed to the anxiety. It's really useful. And then you see that all the data is made of rows and columns, right? So you can just pick some specific rows and columns with this code. So when you make a bracket, the first is for row, and then the second part is for column. So if you write first row and first column, that'll give you 40. That's because the first person of anxiety was 40 here. You want to pick just column. It'll give you all the anxiety column like this. And all row, first row. if you want to call the first row, we just put this as a blank. And then it'll give you the first participant's data at once. Let's apply what we learned before. Like, let's see. What if we call the first through fifth row, first column, that would be 40, 24, 35, 28, 16, which is all the anxiety part, right? Other useful function in basic R is calling the each variable. So first of all, you're gonna call depression, and then when you put this $sign, this all the variable is just pop up. You can see every variable here. You can just select one of these, or you can just write it. So it'll give you all the value of anxiety. You can just play around with other things like race, like this. And then if you apply what we learned in the calculation, you can calculate the mean of this anxiety like this. It's gonna be 28.18. Standard deviation 2. Standard deviation of anxiety was about 9, right? And sometimes there's a case that we want to like subset some data. For example, in this data set, there are men and women, and then what we need is just data for women. So we can do this in R. In depression data, it's going to be a little complicated from now on. So depression. From depression, I need variable name, gender, and then I want this variable to be equal to female. It doesn't matter you put quotation mark or this sign here, it's gonna be the same. And then you should put comma here because this represents the row. If you run this part, it will gonna give you the data for only the female. You can see the gender is all female right now. And then we're gonna assign this data as a depression woman. Like this. So after that, you can analyze this depression woman into like regression or other analysis or something.
Use the row column notation,
Mm-hmm.
and you left the column blank. Right?
Yeah.
Why did you do that?
To get every column.
Every column.
Yeah.
And then why is the female thing in the row?
Because I want to only subset this gender to be female. Yeah, that happened in row, and then I want to get every column for that female. Is it okay?
Yeah.
And then you can do this in other way using the subsetting function. You can just put subset here. I think this is easier way. Yeah.
This isn't interesting.
Right. So put the subset function first, and then you're gonna put data name. I wanna subset from depression data, and then genders, use the gender variables, gonna be only female. This is more straightforward actually. If you click this, it's gonna give you only the data for female, and then we can still assign this to the depression woman. If you want to see this data, It's gonna be only the female, you can see here. Also, you can use the like multiple filter using the subset function. For example, we want to have a male over 30 years old. Then we can do, we're gonna subset the differentiation data. And for filter, I'm gonna put first is gender, which is double equal sign, male, and age over 30. This would give you only the male data with the age over 30. There's age over 30, right? You can play with this function. And then I'm gonna assign this like this. If you have a missing data in your data set or the variable, it not gonna really work. Or I mean, if you want to filter some missing data in your variable, it's not gonna work if you write just NA here. For example, like if you want to subset from the differentiation data, then what you wanna do is just find out some missing data in age. You see there was some missing data in age variable. If you do this, it would not give you anything. So what you should do is not using this one, but use another function name is NA. I think this is stand for, is there missing data in age? And this would work. So it gave us about 4 people which have missing data in their age, and we're gonna call this raciness. Okay, this is how you do with missing data is NA. Really useful and then easy to forget. So try to memorize it, or try to memorize. There is something called is not in this slide, so you can just go back and then check it. The problem is that we don't want the missing data, right? So we're gonna get rid of this data. So what we do is subset from the depression, and then we're gonna only pick the data without the missing, which can be used as this mark. And then we're gonna write, is there missing data in age? And it only give you the complete data set without the missing data. So this is really useful to like delete some missing data in your data set. Okay, so I think we finished to make some complete data set, and I'm gonna try to save this. So save function is called write CSV. And then first option is that you're gonna put the race complete data that we just made in RStudio. And then you can put any title that you want to use for your file. I just gonna use differentiation clean because I cleaned this data. And then you should put CSV here, comma. And there's one more argument that I want to use is row names is false. This is because if you skip this, it's gonna save all the number of row in your CSV. So it's a little annoying. You can just save the data like that, but I just want to delete all the row the value. So I always put this argument like this. Row name is false. So if you save this like this, you can save this file into the working directory that you already set. So check that if your data can save into the folder that you set. and then open it and try to find if the row name is there or not. Okay, anyone has a question? Okay, if you have a question, just come to me or raise your hand and Adam can answer the question as well. So I think this is all for the first session. So we're gonna have just 5-minute break, and then we're gonna start to plotting some data and then do some simple and easy analysis in R. Okay, thank you. Yep.
Oh, this is a file that. Thank you. You can use this trick instead of purple.
Yeah, it's space sensitive. That's fine. Okay, thank you.
It's fine, represent not missing data. You should have just kind of subset data without this. So you raise it, it's gonna keep some data in each variable. When you show this mark, you just get rid of this data in this case variable. This one using. Yeah. And then I then you can use hyperspectral. Like for example. Yeah, I can choose. Yeah. I want to. So from the.
Okay, I think we can start up again. Hello, everyone. We're going to go quickly through a little bit of plotting and some data modeling in R. We're going to continue using the depression data set. So I hope you still have it loaded on. If you don't, then it's a good exercise to try to see if you remember how to do it. And then if you have any trouble, then Youngri will come around and help you. I'm gonna, unlike Youngri, I'm gonna use the slides a little bit. Plotting and modeling are actually, they go hand in hand, right? They're, you know, plots often imply some sort of model, and models can be evaluated with plots. And so it makes sense to kind of look at them simultaneously. So that's what we're gonna do. Just for a couple of different questions. I wanted to say a word about plotting in R. There are some, they call them base R. They're kind of automatically loaded into R when you start. They're functions that plot things for you. And they work nice. You can make some nice plots that way. It's a little bit clunky and doesn't look as nice. There's a newer fancy schmancy package that they came out with a few years ago. Called ggplot, and it was contributed by some external researchers, and it makes some like really beautiful, intricate plots, and it's really great. I put this in a paper that I kind of like it. It's got like you can put function lines and dots and box plots and all sorts of things. It's very very flexible that way. So I kind of like it, and that's what we're going to use. There's a it actually kind of comes from this whole philosophy of how statistical graphics works. It comes from a book called The Grammar of Graphics. That's what GG stands for. And yeah, maybe one day we can do a whole workshop about it. I think that'd be cool. But in the meantime, we're going to use this one function that is in the package called qplot, which I think stands for quick plot, but it's like a shortcut. It'll get you a long way there. So when we mentioned packages at the beginning, that's really where R gets a lot of its power from. Base R that does a lot of cool stuff, but doesn't do anything really cutting edge or that exciting. But individual professors, researchers, whatever, write packages that they contribute. So whenever someone comes up with a kind of new method that they think can generally be applied to a lot of different data sets, they'll write an R package, and it has the custom made functions and well, that's sort of functions mostly. And you can download it from the internet and load it onto R, and then use all those functions and implement their method that they wrote up in their paper. And it's a really nice thing about R. Other packages have that too. R, I think, is the one that statisticians tend to contribute to the most. And the first time you use a package, you have to install it. Some packages actually come pre-installed, but generally you have to install a package the first time you use it. But it's very easy. There's a function, install.packages, and then in quotes the name of the package. And so our package is actually called ggplot2. Forget the 2. And you can do it. There's a point and click way to do this too. I think it's in tools. Install packages. Yes, you can do this and right. Plot 2. I don't know if you can read that, but if you click install that packages, click install packages in the tools menu. That's another way to do it. I'm not going to install it because it's already on this computer. But if for some reason you have it installed already, then you don't have to run this line of code. But otherwise, you should. So if you have any trouble installing the package, then Signal and Youngry will come and help you. Unless everyone's having trouble, then we'll both walk around. But is it working out? Okay, good. Okay, so that you only have to run once. In fact, I'm going to comment it out so we remember not to run it in the future. Unless they come out with a new version, in which case you want to run it again so that you can uninstall the new version. Okay. Every time you start a new R session, you need to call the package so that it knows that you're going to use it. Put it in quotes or not put it in quotes. You get to choose. And okay, so now I can use ggplot functions with that come from the ggplot package because I use this library command. So the first thing we're going to look at here is this BDI, which forget what BDI is supposed to stand for. Anxiety, right? That's what it is. Anxiety. So we want to know kind of like, how is this distributed? And we can use the quick plot function. So actually, let's say I don't know how qplot works. So I'm gonna look at the help. You might want to follow along because this is. I don't know, is there any way to make this bigger? I tried Control+ with this thing. It works on these other windows, but not on this one. Anyway, so it tells you can put in an X variable and a Y variable and other stuff, data, and it explains what to do. But we only have one variable, an X variable. So let's the X variable along the X-axis will be BDIT1, and we're calling it from the data set of depression, right? So I didn't need to tell it, I could have done X equals over here, right? Because that's the name of that argument. But I didn't need to because that's the first argument. The first argument, you don't need to name. But data comes, much later. So I didn't need to name that argument so that it knew that's what I was talking about. If you run that, it'll give you a histogram. It'll tell you that you should pick a better number of bins than 30, which makes a lot of sense. You have a lot of options here, actually. So by the way, it's smart. I mean, it knew that I was looking for a histogram because I only gave it one continuous number. If I had given it something else, it would have given me a different kind of plot. If I wanted to be absolutely sure, the kinds of geometric figures they plot are called geomes, kind of ggplot speak. Geome equals, and I would have been sure it was going to give me a histogram. Same thing, right? Now there's a lot of options you can mess with. let's say I want let's maybe I want to label the x-axis as anxiety. So I can add that option and can label the y-axis. I can maybe, you know, maybe I only want 10 bins. So right, bins equals 10. I should put this on several lines. Oh, so someone asked about number of lines before, or how it knows the line is over. Basically, as long as the command isn't finished. See, I'll do that. As long as the command isn't finished, as long as the command isn't finished, then it'll expect more, right? So if I were to run this without the closing parentheses, then it gives me this little plus sign, which means, hey, I'm expecting something else, right? But if I put this parentheses there, then it knows that the command's finished, and then it doesn't enter it anymore. I'm going to rerun this whole thing, but all right. So that's a histogram, and that's kind of how qplot works a little bit. You put in x and maybe a y variable, and then which data, and then whatever other options you're interested in. So we'll see some more examples of that. Okay, so for the rest of the talk, the workshop, I'm going to imagine we have research questions. So here's changing the colors. Oh yeah, I forgot. I have to tell you how to save. Right. So you made this beautiful, beautiful figure, and you want to put it in your paper. You need to know how to save it. So there are two ways you can do it. One is on the command line. The nice thing about doing things with text by writing out commands is that it becomes replicable. If you have a file saved with all of the commands you ran, then 2 weeks later, when your advisor or collaborator or whoever is like, wait, where did that number come from again? Or how about you change this? You can go back to your code and rerun it, or change it, or answer whatever questions they have about where every number comes from. And this, so many times in my career so far, it's been, I've had to go back and try to figure out where something came from. And the better I am about writing out every line of code that I do and saving it and keeping it that way, the better I'm able to answer those questions. I'm pretty good at it, actually, but it took a while to train myself to do everything right. Okay. So ggsave is also very smart. It saves whatever the last plot is that you made. And if you give it a file extension, it automatically saves it as that type. So if I run this, it'll just save a JPEG file of the last histogram I made. And it gives you automatic size. You can, got other options. So you can do like, make it really big if you want for some reason, and it'll make a really huge file. And just like everything else, if you want to know exactly how it works, or not, if you want to know how it works, just use the question mark and then the name of the function. File name and plot equals last plot. So the last thing you did, that's the default. If you want to plot it, if you want to save a different plot, you can put in a different plot there. And scale, width, height, units, et cetera, et cetera. All right. The other way to save a plot, if you click on the plot tab there, it's still there, is if you click on export right above the plot figure. I don't know if you probably can't read this here because it's tiny, but on your screen, there's a button that says export right on top of the plot. And then you can save it as an image, save it as a PDF, copy to clipboard, you know, save as image. Now it's going to do however you want like that in the point and click style. All right. Oh yeah, sure. Go to export over here and then like that. Cool. Good, good. Oh yes, let's stay with height and width. Good. Okay, so now I want to know, how are age and depression related? Are older people more depressed, less depressed in this data set? So the first thing you might want to do is a scatter plot, right? You have two continuous variables, age and depression. So let's see how they're related in a plot. I always tell people, plot your data before you do anything else, right? Kind of common sense, but not always followed. So you can use qplot for that as well. And on the x-axis, we'll put age. Wait, I hope I'm getting these right. Oh yeah, did you learn about the names function? In case I, so R is case sensitive, right? So if it were capitalized in the data file, but I didn't write out capital, it would give me an error. So so I want to plot age in the x-axis, and in the y-axis, I want depression, which is BDI is depression. Okay. So time one depression, and I have to tell it what data file, otherwise it's not going to know when I'm looking at that. And, let's label it. I always want to label your plot. So is and so that this has to go in quotes, right? Because if I wrote it without quotes here, it's instructed to see what the error message would be. If I wrote it without quotes, then it would think I'm referring to the variable age, and I want that to be my X label. And well, I guess it can't find the variable age. But if I do it like that, then it knows I'm talking about the string, the character string age. So it puts that in as the X label.
Maybe it's like a chart tail or a graph tail.
Oh. I don't always know the answer to those things, but this one I did. And there you go. There's your scatter plot. And you see it's got it just deleted the rows with missing values. And it gives you a little warning there. So that's useful to know. Pay attention to the warnings. Sometimes they're meaningless, but often they tell you something that's important to know. So it's good to know that they dropped these 4 missing values. Good, so that's a scatter plot. Now what if I wanted to actually like model this? So, like test a hypothesis about it. So here we would want to do, since it's 2 continuous variables, we could look at correlation. I'm going to do a OLS model, a simple least squares model. Model 1. And the syntax for simple least squares. By the way, there's a keyboard shortcut for the arrow. It's alt. Wait, what is it? It's this one. Alt dash. Alt dash. The function to fit a linear model is called LM, or linear model. And the first, okay, well, let's do what we should always do, and look at the help function. So the first thing it looks for, the LM function, is a formula. A formula. It's a formula. We haven't learned about formulas yet. Formulas are a special kind of object in R. If you go down to the examples, it'll show you. They have tildes in them. So in our example, we want want to know if on the left-hand side is BDI D1, a function of, so you can read tilde as is a function of, right? Since it's LM, it's got to be a linear function. So it's a linear function of age. That's GLM because it's a generalized linear model. I can show you about that at the end if you want. So I have a slide about formulas. I think that's useful to know. So formulas have this tilde in them. That's what makes them formulas. That's how R knows it's a formula. So Y is a linear function of x1 and x2. So it says x1 plus x2. You're not actually adding x1 to x2. They have coefficients in front of them that it's going to estimate. But this is kind of it's in R language, the language of R. The formula is a way to tell the function what variables are contributing to what variables. So don't read the +2 pot 2 literally. And also there's an intercept in the model. It automatically gives you an intercept. And also there's error too. There's regression errors, which is also part of the model. Y isn't literally equal to x1 plus x2, but Y is modeled as a function of x1 and x2. So here, BD1 T1 is modeled as a function of age, and there's an intercept. I'll run the model. You just print out the model, and it'll tell you kind of the call is kind of what you asked the R to do, and then the coefficient estimates. If you want more information, you could write a summary, and let me show you fully what that gives you. So a little bit of information about the residuals, and this is really the good part here. It gives you the coefficient estimates along with standard errors, and then p-values, t-values and p-values. It does a t-test on each of those coefficients. This gives you an R-squared values. The F statistic is useful for other things. I guess we're running out of time, but we could talk about that a little later. But it's the F statistic for the model, whether it does a better job than just a plain old intercept. All right. So that's OLS. Now you know how to run OLS models, or at least simple ones. So that's how it does it. Yeah, you can get confidence intervals. This will give you 95% confidence intervals. If you want a different, not 95%, you could do that too. So level is what you're interested in. So I want an 80% confidence interval. I'll put in 0.8 over there. See, now it gives me 80% confidence intervals. That's nice. Another very useful function with linear models is plot. Gives you a whole set of diagnostic plots. I think, but it gives you them one at a time. So here it's got residuals versus fitted values with a little non-parametric thing in the middle. You want to look for any structure there. QQ plot. This helps you tell if there's like heteroscedasticity or something like that. Looks for high leverage outliers, influential outliers. Anyway, when you learn about OLS, it tells you to look for all these things, right? So this is one of the this is a good way. It gives you a nice set of plots that you can use to check for those things. I always think checking assumptions by plot is much better than all the list of tests they tell you to do. But that's just me. All right, so that's OLS. We can do something else. I think maybe we'll skip the do-it-yourself stuff. We can do multiple regression. That's also useful, right? So it's the same story, right? So now let's say we want to know if depression is a function of age and SES and anxiety. You just add more variables to that formula. So age plus SES plus anxiety. And by the way, changing the order doesn't actually change the model. It just changes how it's displayed in the results. But other than that, it's the same model. It doesn't matter how you add them. I didn't give a plot for this one because it's really hard to plot in multiple dimensions. BDI is a measure of depression. Although it's all fake anyway, so it could be a measure of flying ability, Oh. Huh. What are the errors?
Unexpected symbol and model, so I guess I'm not.
Okay. Younger, she can, I can help you out the best. Yeah, so here's model 2. Multiple regression. We can use a summary function to kind of to see the output. So, right. So now you know how to do multiple regression in R2. Congratulations. Definitely plot. I'm sorry? Oh yeah, sure. Let's look at the diagnostic plots. You should always do that. Diagnostic plots. Yeah, looks pretty good. It's pretty well for fake data. All right. I might be a little worried about these influential outliers over here. See if it changes the results if I take them out or something. All right. Okay. Well, what about something like a t-test? Let's say I want to know if one group is bigger, is more depressed than another. Are men more depressed than women in this data set? It's again, remember, completely fake. So let's go back to plotting here. Y'all familiar with box plots? I love box plots. I think that's where all the action is there. Let's see if qplot knows to do a box plot, or if we have to tell it. Oh, nope, it doesn't. Let's tell it to do a box plot. Hey, there you go. There's it looks like females have slightly higher depression than males, but not by a lot. Probably there's nothing there in this data set. Now, I'm a big fan when the sample size is so big of plotting points along with on top of the box plots. I think do it. So you can plot data points right on top of box plots, so you kind of see where they're coming from. Now it really doesn't look like there's any difference between the sexes in this data set. Jitter, by the way, so if you notice, these points really, the variation in the x-axis doesn't really mean anything. It's just, females, whether you're here or whether you're here, is the only thing that matters. All these points really should be along one straight line, right? The reason, but I told it to jitter. It adds a little bit of random noise in the extraction. so that the plots aren't all, points aren't all on top of each other. So there's some random noise within each of these categories. Just so you can see all the points. All right. So okay. Well, you know, plots are nice. We want our p-values for our publication and everything. Turns out you can use LM for that too. There's a t-test function actually, like you can see right there. It's suggesting it for me. I'm not going to take the suggestion. I'm just going to use my OLS. My trusty OLS hasn't let me down yet. Now I'm looking for, so again, it's PDIT1, but now I'm going to put in gender over here. So I don't know if y'all, you know, how they teach these things, but if you put a categorical variable on the left-hand side, on the right-hand side, sorry, put a categorical variable on the right-hand side of OLS, then then the way it works is it picks a reference category, and then it looks at the differences between all the other categories and that reference category. So we'll see how that works here. Okay, so the reference category was female, and that's because of alphabetical order, right? Female comes before male. So it looks, this is actually the mean for females, and this is the difference between males and females. So that's, you know, I think until recently SPSS didn't do that automatically, but R will automatically pick a reference category and then look at the difference between all the other categories and the reference category, and then, you know, test it like that. And here's your p-value for the t-test. This is testing whether this thing is 0, meaning whether the difference between males and females is 0. That's the null hypothesis, and it is the p-value for that null hypothesis. So indeed, there's not evidence of anything going on in this fake data set. So now you know how to do t-test too. There's if you want, if you're worried about like assumptions and such, you can do you know, something like you know, non-parametric tests too. Well, the non-parametric test didn't give us anything significant either. There's nothing there, but that you know, doesn't rely on any normality assumptions or anything like that. All right, so how are we doing on time? I think that might be the end of our time, but I could show you all more stuff if you want, ANOVAs and logistic regression for anyone who wants to. Okay. So here, let's do an ANOVA since it's basically the same idea. So now let's say regression by race. So it's the same thing, really. Same structure as before. Now we'll put race here, and do a box plot. And you know, I like my data points. So okay, yeah, I didn't tell you this, but in ggplot, sometimes if you want to add new layers to the plot, you use the plus sign. You're not adding numbers, you're adding layers, but it's still the plus sign. I actually find that kind of confusing, but we're adding a layer of jittered points, so there's a plus sign there. Here you go. And doesn't look like much of anything going on there, but of course there actually isn't anything going on anywhere because that's how the data set was made. But you know, in real life, you'll want to do something with these labels that are overlapping, and there are ways to do that, but maybe we'll do a whole seminar about this one day. So okay, now I want to test this hypothesis that all the that all of the you know, racial categories in this data set have the same average depression. So we can do a ANOVA model. So again, it'll choose, it'll take the alphabetically first category, set that as the reference category, and then tell you the difference between all those other categories and that one. So because screen small, it's plotting it all on different lines. I'm sorry?
Can we put this in a chart,
What do you mean a chart?
like another summary?
You can. There are a couple ways to do it. But first, let me show you this one. See if it looks better here. Okay. So yeah, so the intercept is the reference category with it's American Indians, right? And then, these are the differences between all of the other categories and, and American Indian, right? None of them are significant. If you want an overall, the F test here is down here at the bottom. It's that same F statistic as before. That's what we're looking for, and there's your p-value. So if you want an ANOVA table, or actually, so the ANOVA function here, I should follow my own advice and put this up on the here. So maybe that's what you were looking for. Another way to do it is if you use AOV, you can give you a different kind of an image. Like, oh yeah. I see. Yeah. So it's a good question. There's yeah. I mean, I'm thinking about what the best way to do it is. There are packages that will give you tables, nice looking tables. There's one called Xtable. There's there's a package called Knitter, which does a lot of things, but it's got this cable function that makes nice looking tables. R doesn't have stuff built in to give you nice looking tables you can cut and paste, but it's got stuff from packages that make some beautiful tables. Yeah. All right. So we do logistic regression maybe. What do we got in our data set again? Okay, well, whatever. Let's see if we can predict what gender you are, right? Oh yeah, we do have 3 time points. I think in the initial, the first time we did this workshop, it was over the course of 3 days, and we talked about like turning a data set from long into wide, and which is neat, and not so hard to do, but I can show you that too if you want. But, yeah, there are 3 time points. We can look at, see how they're related over time. But I wanted to do logistic regression. Let's try to predict gender. So here, let's make a logic model. This is the problem with word shortcuts to get them wrong. All right. So now it's not a linear model, it's a generalized linear model. So the function is GLM. And gender is on the left-hand side. And we'll see if we can predict it as a function of age and anxiety or something. And then, so data equals depression. Now, there are a lot of kinds of generalized linear models. One kind of a generalized linear model is OLS, right? That's the simplest kind. And actually, if you ran this by itself, it would just do OLS. So that wouldn't work very well. Another kind is, there's a Poisson regression, whatever, but we want a binomial model. If you really want to be very specific, right? Binomial logic, but that's not really necessary. Let me put a new line here. So, oh, no, we didn't like that. Okay. Oh, because this is this is a factor variable or a factor variable. So let's create a new variable. We're going to define a new variable here called female, which is if so now we have a variable called female, which is true or false, but R knows how to knows how to deal with true or false. It treats it like it'll just treat true or false like ones and zeros. Let's run that one. There's a logistic regression, and we can do the same old summary trick here. And here you go. Here's our coefficients. I'm not actually sure what happens if you tell it to plot it. There's only one way to find out. Yeah, it does give you, it treats it like as if it were a LM. It's funny. I don't know why it does that. Okay, those are useless. Anyway, okay, so you got some bonus plots there and bonus logistic regression and ANOVA. Right. I think we can call it good. I'm going to send out an evaluation form, and you need not only say nice things, you can also say mean things, because we'll use them we'll take it as constructive criticism. But please, we'd appreciate it if you'd fill it out one way or the other, because it's useful information. And thank you very much. You can answer some questions now if you want. End the meeting.